Hello students. So in this video we are going to do some very basic questions based on the mole concept, and in this particular video I am going to show you how we find out the percentage composition by mass of the different elements which are present in a compound. For example, we can start with this particular compound, which is ammonium phosphate. You really don't have to know the name of the compound as such, just focus on the formula. Now what you have to take care about is that when you have to find out the percentage of nitrogen, then you have to make sure that you are taking the correct number of nitrogen atoms in the formula. So you can carefully observe that nitrogen atoms are 3. The hydrogen atoms are 4 times 3, that is 12. There is only one phosphorus and there are 4 oxygens. Nitrogen 3, hydrogen 12, phosphorus 1 and oxygen 4. Now you need to know the atomic masses of the various these elements, which you can find out from the periodic table. Nitrogen is 14.01 to 2 decimal places. Here it is hydrogen is 1.008 to 3 decimal places. You can take it as 1.01. Phosphorus is 13.97 and oxygen is 16. So since you know the number of atoms of each kind, the total mass contribution will be 3 times this, similarly 12 times of this, just once phosphorus, and oxygen 4 times. So these are the contributions of nitrogen, hydrogen, phosphorus and oxygen in the total. So let us find out what is the total molar mass of this compound. So we can simply add these values which you got here. So they add up to 149.10. That's the molar mass and its unit is gram per mole. Now this is the total, and to find out the percentage of nitrogen, you need to know that out of this total how much is nitrogen. So you can see it is 42.03. So its percentage is 42.03 over 149.10 times 100. So this gives you the percentage of 28.20. In the same way you can find out the percentages of hydrogen, phosphorus and oxygen. So the total remains the same, that is 149.10, and then you have to take the amount of hydrogen which you see here, the amount of phosphorus which you see here, the amount of oxygen which you see here, and use the same formula and you get the percentages of the various elements which are present in the formula. So this is the final answer. Now obviously if you add up all the percentages, they will add up to 100. That is a cross check that you can do. So this is a similar problem, but it has got more number of elements, and so it will take more time for calculation, but the method remains the same. There are 17 carbon atoms, 15 hydrogen atoms, 3 nitrogens, 2 oxygens and 1 chlorine. Multiply by their atomic masses, which you can find from the periodic table. Find the total for each element. If you add up all these values, you will get the total molar mass of the compound, which turns out to be 328.77 grams per mole. And for finding out the percent composition of each element, this will remain the total 328.77, and then you take carbon from here, similarly hydrogen, nitrogen, oxygen and chlorine, and then substitute for each one where the total remains the same, and then times 100. That gives you the percentage of each element which is present in the compound. So this is the final answer. Similarly for K3FeCN6, you find out the total atoms, but don't forget that carbon here is 6 times and nitrogen is also 6 times. Don't forget that. Then multiply by their relative atomic masses, which you can find from the periodic table. This is the contribution of each element. The total molar mass is the sum of all these values, and then the percentage composition for the individual elements will be that you will take this value over 329.27 times 100 for potassium. Similarly for iron it will be this. For carbon it will be 72.06. For nitrogen it will be this over the same value, 329.27 multiplied by 100 in each case gives the percentage of that particular element in the compound. So hope you understood how to find out the percentage composition of the elements in a compound by simply considering the formula. Thank you very much for watching.